So I'm very pleased. I'm very excited. Bubunyo Nyavor from Ghana. You're dialing in from Ghana, right?
Yeah.
So thanks. That's such a long way that you would have had to travel to Berlin, I guess, wouldn't you?
Yeah, it would have been.
Yeah. And so this is a much less friction way to get there. I'm really excited about your talk, Bubunyo, because you are talking about probably my favorite subject in Go, certainly one of them, which is interfaces. What is it that got you into Go? What brought you to Go in the beginning?
Yeah, so I used to be part of a startup in around 2017, and one of my colleagues, we had to implement one of the critical systems. It was failing all the time. It wasn't scaling properly. And then one of my colleagues suggested that we re-implement it with Go, because Go has all these powerful concurrency paradigms that makes it easy to model our application. And that is where it started. And I've never really looked back. So I think writing more Go makes me a better programmer, and that is what I've always wanted to be. So I continued to write Go. It made me better, and I've never really looked back since. So yeah, great. I think that's how I got into it.
Yeah. Oh, excellent. And your charity that you've chosen is rescue.org. What does rescue.org do?
So rescue.org is involved in helping people, women and children in Yemen get food, get medication that they need, and get all the essential items that they need. Because that place is war-torn, I feel like it doesn't get a lot of press. A lot of issues are quite relevant. Black Lives Matter, Trans Lives Matter, and all of these. But because Yemen is never really put in the spotlight, it gets sort of swept under the rug. So I thought, yeah, I've never been in the position to do anything good for Yemen. I can't go there and protest or do anything. So why not send a donation on my behalf? Yeah, so
absolutely. And I think that's lovely, by the way. And I think anybody that wants to also make any donations, if you really like a talk, why not donate as well to that person's charity choice as well? So this one, rescue.org. Well, I don't want to take up any more of your time. I want to get into your talk because I'm very excited. I love Go interfaces. So without further ado, please clap at home. Make sure you are. And welcome Bubunyo Nyavor.
All right. So so today I want to be, when I submitted the CSP application for this particular talk, I wanted to help developers better understand interfaces in Go. But as I continued to develop the material, I realized that what I'd in fact done was I'd created the missing interface tutorial. So I sort of unofficially changed the title of my talk to be the missing interface tutorial in Go. And yeah, so that is what we are going to be talking about today. So like Matt said, my name is Bubunyo Nyavor. I'm a developer in Ghana with a backend focus, mostly backend stuff. I've been doing Go since 2017. And if you are looking to interact with me, you can find me on Twitter. My username is KidBubu. If you interact with me there, I'll be most happy to engage with you, whatever topic we end up talking about. So yeah, like I said, when I picked up Go in 2017, one of the things that seemed easy at first was interfaces. But as I continued to do more Go, I began to realize that I didn't really understand interfaces. I have some experience in statically typed programming languages like Java, Kotlin. And I got the construct of interfaces in Go and how they were different. One was implicitly implied, and one was explicit. It took me a while to figure out how I was wrong or even why I was wrong. And these are the lessons and realizations that I want to share with you guys and any budding Gopher out there to help them make it easy for them to assimilate interface. I believe that most people find it difficult to fully grasp the concept of interfaces because we learn it, the way we learn it is fundamentally flawed. Most of us who pick up Go do so from some sort of OOP language background or some derivative irrespective of it, and we extrapolate our knowledge of interfaces onto Go. But interfaces in these two, Go and, for example, Java, I'm going to be using Java a lot because that is what I can compare with. Interfaces in Go and interfaces in Java are extremely, just a moment. Yeah, just a moment. Just a moment. Yeah, so like I said, interfaces in Java and interfaces in Go couldn't be any more different because interfaces, interfaces in Java and interfaces in Go are different. And that's when I had this profound realization that in order to understand interfaces in Go, you really need to unlearn interfaces in other languages, because this is the only way you can see interfaces in Go for what they truly are. Now, when we want to pick up Go, a lot of us go with one tutorial: Go for Pythonists, Go for Java developers, Go for Node developers. A lot of these tutorials are great, but I find that a lot of them are, if not all, are extremely lacking when it comes to the concept of interfaces. So before we go on, let's talk about what interfaces are in Go. Interfaces in Go are two things. First of all, it is a set of behaviors. It's a set of methods that defines the behavior between two entities that interoperate. And secondly, an interface is a type. But I'm only going to be talking about the behavior part of the interface because I think Jordan already did justice to interface as a type in his article. If you haven't read it, you should Google Jordan O'Reilly interface, and then I think it will be the first result, and then you can grok that particular concept. So yeah, the main focus of this talk will be interface as a behavior and a set of methods. So to demonstrate interfaces, I'm going to use this contrived example, that is the shape interface. Because when we build complex computer systems, modeling shapes is one of the things we do. So we specify the shape interface with a behavior that is area that returns a float 64. And then we create a function that is print area that only requires the input of a shape, because the only thing it's interested in is using the area behavior in that particular function. And in this particular case, it is just printing it out. Now the circle struct can specify its data type, but then it also goes on to specify the area, just like the interface, the shape interface, and then adds the body of, or adds the process of computing an area to that particular, to the circle struct. So it means that because the circle fulfills the shape interface, we can easily pass it as a parameter on line 19 to print area, and then this will print out 78.5 as the area of the shape. That is well and nice, right? Cool. Now, most tutorials will tell you that, okay, hooray, now we've done interfaces, and you know some interfaces. So go forth and conquer the world. But they are just wrong. By stopping at one interface for shapes, we miss the chance to say something vital. Go interfaces are not a variant of Java or C# interfaces. They are much more. Interfaces in Go help you build complex behavior through implicit composition, and we are sort of going to get into that as we go along. I think this is where most tutorials fall short in helping you figure out how to specify complex behavior through compositions. They do all the work of defining behavior sets but they leave you with the exported knowledge or transported knowledge from other languages like Java, and then when you sort of use this exported knowledge to build your applications, that is where problems start to arise. From the example I showed earlier, you can also glean that one of the most obvious things about Go interfaces is a lot of us will know this. There's no literal or keyword to signify the implementation of an interface detail. It's implicit by design. So if it was explicit, it means that if the behavior changed and we needed to, if the behavior changed, it means that all structures or all classes that depend on the particular shape interface would have to change. Now, this will become a problem if you have a very large system and there are quite a number of files in there there will be quite a number of files in there that you'd have to change to get your implementation to compile the first time. I don't think this is something a lot of us will want to do. So we want to specify a new behavior for our shape interface. We want to call it perimeter. But one thing to also notice that in reality, the process involved in specifying new behavior never really starts from, I want to add a perimeter function to my circle struct. It often starts from a new problem that arises that you need to solve. So in this particular case, it's going to be like, I want to be able to get the perimeter of anything that has a boundary so that if it's time to buy a lanyard, we know exactly how long of a lanyard to buy. And in doing this, in going through this particular simple thought process, we have discovered the behavior that we want to design for. And this is, I think, one of the key things when it comes to working with interfaces. You don't have to design with interfaces like in Java, but in Go, you sort of discover them as you go along. If we had to do this in Java, specify the perimeter behavior in Java, what would happen is we have our shape interface, we add the perimeter function to the shape interface in addition to the area, and then we sort of have to modify the circle struct to implement this new perimeter. But this will become a problem, especially if you don't own the shape interface implementation. It means that you have to go talk to someone about changing their implementation, and the protocol involved is something I don't think a lot of us want to do. Like, I just want to write code, implement my perimeter. Why do I have to write an entire proposal as to why we need to add a perimeter interface? And in large enterprise systems, this is sort of like what happens. They sort of design with interfaces because, so I've been involved in some Java systems where some specialist architects have been brought in to sort of model the entities, model behaviors, and then create interfaces that are set in stone. And then if there's a need to change it, it means that we would have to go through the whole committee setting, the whole specialist architect, defend why something needs to change. And yeah, I don't think a lot of us want to be writing code like that. I think it's one of the reasons a lot of us have moved from languages like that into Go. In actual sense, initially, this might seem like a good idea because if you think about the complexity of some of these systems, given the language you are supposed to be working with, a change at the top of the hierarchy is going to cascade all the way down across multiple teams. So you don't want to be able to do that easily without coming up with a definite, concrete reason as to why you need to change something, as to why you need to implement a simple behavior or change it. Water break. Yeah. So yeah, but if you wanted to do this the Go way, rather than adding a new behavior to the shape interface, it makes sense to define the perimeter behavior in its own interface. And we specify the boundary interface and then add the perimeter behavior for what it's supposed to be doing. In this particular case, when we implement the perimeter interface like we've done on line 33, the method is sort of detached. And this is one of the profound things about Go and the way methods are detached, because it means that the data remains sacrosanct. You don't have to be going back and forth between files, specifying behavior, changing implementation. And as you discover new ways, as you discover how to solve your problem, there's no round trip of going back and changing interface and specifying behavior and then coming down. So yeah, you don't have to spend a lot of time doing this back and forth. You can sort of just easily implement this as you go along. And the perimeter function will only have to deal with the function that the interface that it only relies on. That is the perimeter behavior. Now, this fulfills, I think, one of the most important principles when it comes to software engineering, the solid design principle put forward by Robert Martin. And it fulfills the I in the solid principle. That stands for the interface segregation principle. It basically says that clients should not depend on methods that they don't use. It makes sense in principle because you don't want to create dependencies, or you don't want to create the opportunities for people to have behaviors that they don't depend on, because it opens the door to do something wrong and get it wrong in the at the end of it. So you realize that on line 35, the print perimeter function only depends on the boundary interface, which only specifies the perimeter behavior, and that is the only thing. Now, because the circle struct has implemented the perimeter interface, there is no there's no coupling between the boundary interface for getting the perimeter and then the shape interface that I introduced earlier for getting the area. So you can use this in an as and when you please. And if you run this, you'll be able to get the area, which is 78.5 for the circle, and then a perimeter of 31.40. Now, this also, keeping the interfaces small and independent, also brings to light one of my favorite quotes from Rob Pike. He said, and it's a good proverb, and he says that the bigger the interface, the weaker the abstraction. Because if you keep the interface implementation small, it gives you the ability to orchestrate these interfaces and compose them in the ways that you think make sense to the particular entity or function that depends on a particular interface. I mean, the entire Go ecosystem depends on very small interfaces. And the three most important interfaces in the Go ecosystem, the reader interface, the writer interface, and then the empty interface, they have an average of 2/3 methods. So yeah, I think keeping the interface small makes it really powerful to abstract and then compose. One thing you would also notice around on the implementation I just showed you was that the design appears to be data-centric in the sense that the data is defined without dependency on the behavior. And as we go along, the behavior sort of flows as we discover the problem. So yeah, in this particular case, you don't have to go back and forth. You just continue to implement the interface, write your interfaces, and go on to model your application based on the problem you have. And in this particular way, the data, which is the struct that contains the data, remains sacrosanct. So it remains pure in that particular sense. So yeah, essentially, Go interfaces will help you specify behavior, but learning about how to specify behavior alone makes it very difficult for you to learning about specifying behavior alone shortchanges you in the sense that you sort of extrapolate knowledge from Java and Java and C#, and you sort of want to implement your applications the way you did it. But you really have to do a lot of unlearning in Java, and a lot of unlearning, especially when you come from Java and then the C# languages. And once you are able to get this right, it's very easy for you to create you can easily create complex systems by creating these compositions from your interface. And I think it's an important question to ask ourselves anytime we go to design systems, that this behavior that we are specifying, is it really does it contain all the dependencies that all the behaviors that we need in this particular systems? Because as you go on to answer those questions, you realize that the result of those answers is a system that is better designed, a system that is better to understand, and a system that you spend less time trying to break a design from the language. So yeah. So that's it about interfaces from me. If you'll be able to send your questions, I'll be able to answer them. Yeah.
I'm going to do a round of applause on behalf of everybody. Thank you so much. That was great. I do want to see if there are some questions. Ask them in the event chat if you want me to ask them. Some people are just putting applause in quotes and asterisks. I think that's how we should do it from now on anyway. I love the fact that you say you have to kind of unlearn interfaces in other languages, because it's true, they are different in Go, aren't they? They feel different and they behave differently.
Yeah.
I think that's a very good point. Yeah, the other thing I liked was that your example with the ship interface is very easy to mispronounce. So it's very you did a great job not mispronouncing that. I can tell you, I've written some ship interfaces in my time, and I've had to, delete them.
Yeah.
Okay, so I'm just getting just general applause. I don't know that there are.
All right, thank you.
Yeah. But what's your Twitter name again? Because I think.
Yeah, so it's Kid Bubu, KIDDBUBU.
Kid Bubu. Okay.
Yeah.
That's a great Twitter handle. So if you want to ask any other questions, please do so there. Okay, great. And I'm going to now move into the showing off that quiz thing. He's just gone. So this was the quiz earlier. What does this print? And the answer is pace. And you sort of have to know about all the different ways in which defer work here. But it's quite a fun little exercise, a little adventure that you sort of have to unweave. And pace, of course, it's a shameful plug of a minimalist project management tool that I'm building with David Hernandez, pace.dev. I wanted to also show you this. Natalie Pistonovich earlier asked, which Go version are you using at work? And look at these results. It's quite interesting. It's nice and quite encouraging to see that most people are using the latest version. And that's the one nice thing about Go. Because of that 1.0 backwards compatibility thing, you can upgrade with confidence. It's not like other languages where there'd be a lot of work in a major version kind of upgrade. You can generally update the tooling and things just work. And obviously, if you do testing and things, these other practices, you can have even more confidence with that. I was a little bit dismayed to see 10% of people say that they aren't using Go at work at all. And I think that's kind of a tragedy. So anything we can do to help there, that's what we want to do. We don't want you to be not using Go. Because once you start using it as your day job, it changes everything. It stops being side hobby language, and you really get to do some real good damage with it as a production language. So it's very cool. So yeah, I feel for you, anyone that doesn't get to use that at work. We have another test, another break now coming up, starting now, and it's back at 10 to. So this is going to be 50 minutes past this current hour, which is how we now tell the time in this dystopian future. And I'm going to leave you with this other quiz, and I will tweet this one too. I want to know what gets printed here. So tell me, please, with yourselves. And we'll see you after the break in about 10 minutes.